Hi guys, if you ever wondered what a box plot is, then you've come to the right place. By the end of this video, you will know exactly what a box plot is and what the different values on the box plot represent. Let's begin by plotting a simple box plot with iris sepal width. You can see on the screen there is a box plot here. The thick line in the center represents the median. The box represents the quartiles, and the edges, the whiskers, represent the minimum and the maximum value. The bubbles that you see there, well, these are your outliers. Having looked at the overview, let's start with the basics first. The basic of a box plot is the median. Now, I hope you all know what a median is. We will quickly go through a simple example of what a median is before progressing further. We create here a vector of 5 numbers and a vector of 6 numbers. We'll call them vector 5 and 6 respectively. And let's just quickly sort these vectors. Now, when I print this vector 5 to the console, I can see that the midpoint of this vector is 12. This corresponds to the third value in the vector. As far as vector 6 is concerned, there are two midpoints, 6 and 9, that corresponds to value third and fourth in the vector. Therefore, the median of the vector should be the mean of these two values. Let's just quickly verify that using the median function in R. Great. Now, let's also check the median for iris sepal width. That's 3. If we look at this box plot, the median corresponds to 3. That makes total sense. Now, in order to understand this box, we need to understand the concept of quartiles. In order to look at the quartiles in R, we need to use the function quantile. Let's quickly do that. I'm also going to get the quantiles for sepal width. Now, what we see here is a set of 5 values. Now, these 5 values correspond to 5 different positions within a distribution. So let's say you have a distribution of data in front of you. The first value represents that we see here, that corresponds to 0, is your minimum value. The 100% is your maximum value. The 50% corresponds to the median. The 25% mark is the point beyond which lie 3/4 of the value and below which lie the 25% of the values, or a quarter of the value. So on this particular chart, you will be able to see that the values that lie between this thick line and the bottom edge of the box are the values between 25% and 50% mark. This 25% mark is your quartile 1, and this line at the top, which is the top edge of the box, represents the third quartile, or the 75% mark. Now, there's another interesting concept here that we should be aware of, which is very useful, and that's called interquartile range. What is interquartile range? Interquartile range roughly refers to the length of this box. It is defined as the difference between quarter 3 and quarter 1. So Q3 minus Q1 is your interquartile range. Now, why is that important? Interquartile range basically gives us a sense of what would be considered to be an extreme value within a distribution. So let's say you calculated your interquartile range. Anything that is 1.5 times beyond quartile 3 and quartile 1 are considered to be extreme values. So in this particular case, our quartile 3 for sepal width is 3.3. So if we multiply 1.5 with 0.5, which is the difference between Q3 and Q1, and add that to Q3, we will get your first extreme. To get the bottom extreme, we will reduce the same product from quartile 1, which is 2.8. And that would give us what is also called fences. Any values that are beyond this point in a distribution are considered to be essentially bad values. Now, if you look at this particular box plot, you will see that the minimum value is 4.3. Even then, the value that has been plotted here by the top whisker, which is supposed to be the max value, it corresponds roughly to 4. If you look at this value here, this does not correspond to the minimum value in the sepal width. Why is that? Now, to be able to explain this point, I'm going to print the sepal width distribution sorted in an ascending order, and I'm going to print that to the console, and you will be able to see that even though the minimum value is 2.0, what gets plotted here is something between 2.0 and 2.5, and even though the maximum value is 4.4, what gets plotted here is something around 4.0. And how do we get to that value? Well, we get to that value by looking at max iris sepal width, which is 4.04. So any value beyond 4.05 is considered to be bad value, and therefore the max value that is plotted is 4. And any value that is lower than the minimum iris sepal width acceptable is 2.05 is considered to be a bad value, and therefore the value that's plotted here is 2.2. Well, that's all I have to share with regard to what is a box plot. If you have any questions with regard to this, please leave a comment. If you want to know how to plot a box plot in R and how to interpret a box plot in anywhere, well, check out my other videos.